I will explain about the earthwork pipe for this project. First of all, the proposed temporary earth drain. This figure presented the proposed layout of a temporary earth drain. In the legend for this figure, it shows the flow of temporary earth drain, water flow direction, proposed wash-through location and proposed slope protection. The calculation method for temporary earth drain is by referring to mass mark. The nearest platform level to the proposed sedimentation pond is 55.80 meter. The depth of the proposed sedimentation pond is 2 meter. Thus, the sedimentation pond inlet level is 53.80 meter. Next, we proceed to the cut and fill calculation method. This figure shows the grid method of cut and fill calculation. Drawing a grid on the plan for the earthwork project is the grid method of calculating. Calculate the cut or fill necessary for each grid node based on the existing and expected ground levels. Moreover, this should multiply the cut or fill depth by the area of the grid cell once it has been calculated. Lastly, for each cell in the grid, the average cut or fill depths are determined. The volumes of each grid cell may be computed using this depth, and the overall cut and fill volumes can be derived by putting the cell volumes together. Then, we proceed to the problem and solution for the earthwork. Earthwork is the process of excavating, transporting, and compacting the earth's surface at a similar location. Earthwork mostly done during the early stage of construction. Some of the most typical problems found in the earth excavation and site grading are improper compaction, incorrect final elevations, and working beyond the designated area to be disturbed. The following below are some examples of earthwork problems and their solutions. The first problem is soil too wet. The solution is it must be exposed or mixed with drier materials. Second problem is soil too dry. The solution is water should be added into the soil. The third problem is soil leaf for compaction too depth. Solution is listen leaf depth. And the last problem is different type of soil. Solution is check if the proctor test, the test which measures the density of the soil sample for other tests to be measured against. Match the type of soil encountered.
For the proposed route design, the layout is showing the finished route level that proposed by us, and for the route width is 9.15 meter, type is 2 way per length, and the floor is 1 misbah 40. And the thickness of bearing cost is 40 mm, and the thickness of binder cost is 60 mm, and the thickness of grade crush is 300 mm. The higher proposed level in this project is 55.9 meter, and the lower proposed level of this project is 48.5 meter. Drainage. This is the layout of the drainage design. The blue color is showing the proposed perimeter drain, and the red is showing the existing main drain. And the green arrow is showing the water flow direction. Proposed design drainage calculation is using MAMAS tool as the reference to calculate the drainage design. First is determine the rain gauge location, which at the Sungai Lembang PCC Mili Pahang, so that it can find the I and the Q peak. Other than that, it can find the required minimum depth, which is 0.80 meter, which has the bigger Q peak, Q allowed than the Q peak. The Q allowed is equal to 1.332 is bigger than the Q peak 1.150, so it's okay. For the velocity, V is equal to 1.85, so also okay since it is smaller than 2.0. Okay, so the drainage dimension proposed will be the width is 0.90 meter, and the depth will be 0.85 meter, and the velocity will be 1.5 meters per second, and the discharge Q is equal to 1.332 meter cube per second. Okay, for the proposed detention pond, it is placed at the lower place of the area, and the proposed detention pond level based on the even level of drain. Proposed platform level is equal to 48.4 meter, and the proposed depth is 2 meter. Therefore, the even level will be 46.4 meter. The level base of detention pond is 46.4 meter from the sea level. Problem and solution about root and drainage. The first problem for the root is subgrade to solve. This is a different aspect from the rear and root frame provider. The contractor needs to increase the time for compact. However, it will make a more cost needed for construct the root. The second problem is the root zinc after done. Therefore, the best way is dig up the upper cost and compare against the subgrade. However, it is need a high cost, hence the most of contractor will choose to using outward cost refill the sink only. For the problem for drainage, the drainage is no fat or cube, which is a little sink in the middle cause the water cannot discharge well and stuck at there. This will happen is due to unwell leveling during installation and mistake by the worker. The solution is to build the part that are well leveling. However, some contractor will pass a layer of concrete on top to make it flat due to it is easier and save cost. And the last problem for the drainage is the drain is destroyed due to soil-based sink. Solution is replace the part where destroyed.
Next, I will explain about the proposed water reticulation layout. This figure presented the proposed layout of water reticulation. In the legend for this figure, it shows the flow direction for water reticulation, proposed fire hydrant, proposed sluice valve, and proposed core valves. The quantity proposed for fire hydrant is 3 pieces. The quantity proposed for sluice valve is 4 pieces, while diameter proposed is 150 mm until 375 mm. The quantity proposed for core valve is 1 pieces. The diameter is 150 mm and 200 mm, while the installation pipe is 100 mm. Next, I will explain about the water demand calculation method. The total number of houses for this project is 49 houses and the required capacity is 73.500 mm3 for the determination of water demand. The new proposed platform level is 51.0 meter and the existing platform level at the main pipe is 51.0 meter. The distance from tapping point to bulk meter is 5 meter, while the distance from bulk meter to suction tank is 7 meter, which is based on the reticulation system diagram. The design only considers pieces by friction, the others can be neglected because they are too small. The loss by friction could be determined by using Hazel-Williams formula. Residual head pressure at the end of the node could be determined by using Bernoulli equation. Finally, the tapping point to the bulk meter at the bulk meter to the suction tank need to be calculated by using the formula given for water demand. Next, we proceed to the problem and solution for water reticulation. Water reticulation system are water distribution system that collect and treat water before distributing it to consumers. Water systems are now often distributed through an infrastructure that involve pipes made of plastic, metal, or even concrete. Pressure and the energy supplied by that pressure are typically used to transport water to its finishing destination. The following below are some of the issues and solutions related to water reticulation. The first problem is the amount of water necessary to keep the system running is expensive. The solution is this movement can be supported by gravity, which is beneficial for a less expensive operation. The second problem is the main pipe is leaking. The solution is the leaky pipe should be repaired as soon as possible and regular checks and maintenance should be performed. The last problem is choosing the incorrect pump system can cause the system ability and capacity to fail. The solution, the pipe size must be calculated based on the water demand of each outlet to prevent any mistake occurring. Thank you.
Proposed sewerage design is showing the plan of the sewerage. Okay, the red color line is showing the HDPE pipe, and the circle, orange circle with the red line is showing the manhole, and the blue color is showing the flow direction of the sewerage. Okay, the place that need manhole is the starter upstream of all sewer, every change in gradient, every change in the size of sewer, and all intersection and junction. Okay, the design detail is the sewer shaft is equal to 450 mm in diameter, and the gradient is 1:200, and the manhole size is 760 mm times 760 mm. For proposed STP design, it is placed beside the detention pond. The proposed level based on the inverse level of the sewerage. The proposed platform level is 48.4 meter. The proposed depth is 3.35 meter. Hence, the inverse level is equal to the proposed platform level minus the proposed depth. So we can get 45.05 meter. The level based on FTP is 45.05 meter from the sea level. Total population equipment PE By follow the standard of the resident house will be considered the maximum it has 5 per house PE. So we can calculate all the quantity of unit or house in this project. So type 5, so we can get the total is 245 population. Problem and solution about the sewerage wall. The first problem is the joint of sewerage pipe is leaking. The solution is will occur due to the ground movement or vibration occur when the plant and machinery of site pass by. And it should install and make a mark to avoid plant and machinery pass by. And the second problem is the sewerage pipe is blocked. This will occur before and after the building hands over to the client. For before handover, it may occur due to the construction material not intentionally fall into the sewerage pipe in toilet during construction work, especially cement and concrete. Therefore, the contractor should unblock it before hand on to client. Normally, they will use something hardener such as steel rope to unblock it. The last problem is sewerage pipe is destroyed due to the sink or subgrade. The solution is repair the pipe where destroyed.
Okay, next is method statement. So what is method statement? Method statement is a document that gives detailed explanation of how to carry out work safely. The purpose is to describe the safety precautions to put in place to control risk identified in the risk assessment. So among the four method statement, I will choose two, which is in infrastructural part. I will focus on method statement on site clearing. So what is site clearing? Site clearing in this method statement, I stated that it aims to focus on site clearance, grubbing, and topsoil removal. The process of clearing and grubbing to remove off all trees, bushes, vegetation, rubbish, and any other relevant obstruction within line of the work project. Okay, so what is the standard that we are following? The standard that we are following in these site clearance activities is that first is the Malaysian Standard or British Standards Code of Practice BS6 031981, and then Manual Saliran Mesra Alam Malaysia MSMA where applicable. And then the process of removing all existing structures with a safe approach, for instance, walls, fences, drainage, water pipes, and cables while ensuring its existing usage still resumes. This is also include the site clearance activities rather than the upper one. And then the safetiness that we have to take is to ensure that all safety precautions and recommendations outlined in the risk assessment have been applied. For example, the operators are qualified, hold license for machine operation and trained in the maintenance of machinery. And lastly, to include all pertinent personal protective equipment PPE. So these are some example of precautions that we have to take when doing the site clearance activities. The second method statement is pavement work. So pavement work, what have we done is here is application and lay pavement for the road, concentration consisting of subbase of granular material, road base for crusher run, asphaltic concrete binder course, and asphaltic concrete wiring course. So the standard that we have followed are, the first one is Arahan Technique developed by JKR and other guidelines from British Standard. So the work sequence flow that we have put into this making pavement are, the first level is thick sand course, second one is thick well compacted crusher run, the third one is thick asphaltic concrete binder course ACB20, and the fourth one is thick asphaltic concrete wiring course ACW14. So the precautions that we have taken is by health, safety, and the environment plan will be at the site to guarantee smooth running and work area. So some of the precautions that we have taken are, first, safety induction to be conducted to all new workers. Safety toolbox meeting shall be conducted every day. The third one, all workers shall be provided with PPE, which is personal protective equipment, and shall be worn at all times on site. And the fourth one, advise to report any accident or injury to the supervisor. And the last one, proper and adequate provision of temporary signage and barricades at diversions and temporary haul road as necessary.
Hi and Assalamualaikum. My name is Nurul Isnani binti Azlan. In this video, I will explain about esteem software that used for structural pipe. We are required to propose the suitable size for use to all beam and column with the suitable thickness for all slab in this software. The position and arrangement of beams design has followed the structural drawing that we got from XZY Consultants Sdn Bhd. For beam size, we are proposed to use two types of size, which is 150 x 400 mm and 150 x 250 mm for GB, 1B and 2B. Meanwhile, the size column that we have proposed to use in this design is 225 x 225 mm with the 270 mm thickness at GB and 125 mm thickness at 1B. Therefore, for slab, 3D view that we have designed for this project. Foundation, we are using that foundation that has divided into two, which is file foundation and drill shaft. And in this project, we designed by using file foundation, which is 5 type of file foundation with different dimension has been remarked as P1, P2, P3, P4 and P5. The 5 type dimension that used was different, but the file size for these all 5 foundation was same, which is 150 x 150 mm with 20 tons of file capacity. Furthermore, the structure member size used in this project were proposed based on the actual drawing that we got from SLY Consultants Hendran Berhad, but some size used in this drawing were different from the actual size for beam, slab and column. So for beam, we proposed 150 x 400 mm to use in GB and 2B level, while at 1B level we use 150 x 400 and 150 x 150 mm at beam. Next is the two type of column size has been used in this project, which is 225 x 235 mm were used for floor to B to 1B, while 125 x 225 mm and 400 x 500 mm were used for floor to B, 1B to GB level. Other than that, slab weight is a significant part of the structure. The load and the thickness of the slab must be determined early in the design process. In this project, the slab thickness was different for the GB level with 1B and 2B level, which is we used 270 mm for GB and 125 mm for 1B and 2B. Next is some type of reinforcement has proposed to use in column, slab and beam, which is for the column, we'll use reinforcement as main bar, outer and inner ties, such as 4010, 4016, 4012, RT16 and 6016 has been used in main bar, while RC100, RC125 and T10105 were used in outer ties, and 2T10175, T10175 has been used in inner ties. The reinforcement that used in the slab was divided into top reinforcement at slab support and bottom reinforcement at mid span. It was used BRC B7 at top reinforcement at slab support, and T10200, T10175 and BRC B7 were used in bottom reinforcement at mid span. Last but not least, the reinforcement will use at the bottom and top in the beam with the different type at each level. The two T12 at the top and two T25 to T12 and two T20 at the bottom was used for GB level, while at 1B level it used 2 T12 and 2 T16 at the top and 2 T25 to T12 and 2 T16 at the bottom, and level 2B it used the same type of reinforcement at top and bottom, which is 2 T12, but the size that proposed by STEM still needed to calculate by manually to ensure the size was correct.
Next, for manual calculation of slab, while for specification, the long span LY is 3835 mm and LY-LX is greater than 2, which means that the slab is one-way slab. And the short span is LX is 1300 mm and the permanent GK is 2.0 kN per meter square, and the variable QK is 3.0 kN per meter square, and the design life is 50 years, fire resistant is R60, and the expression class is XC1. While for the material, the strength of concrete FCK is 30 Newton per millimeter square, and the character strength of steel is FYK is 460 Newton per millimeter square. While the unit of reinforced concrete is 25 kilonewton per meter cube, and assume bar is 20 mm. While for the loading and analysis calculation, the step self-weight is 3.125 kN per meter square, and the design action is 11.42 kN per meter square, and the bending moment is 11.19 kN per meter, while the shear force is 7.4 kN. Next, for specification of simply supported beam, the effective length span is 5.5, and the dimension is 150 mm, and the depth is 400 mm. And the characteristic action, the permanent GK is 18.08 kN per meter, and the variable QK is 8.28 kN per meter. And the design life is 50 years, fire resistance is R60, and the exposure cement is XC1. While for the material, the unit weight of concrete is 25 kN per meter cube, and the characteristic of strength of concrete FCK is 30 kN per meter cube, and the characteristic strength of steel FYK is 460 Newton per millimeter square, and the strength of link is FYK is 460 Newton per millimeter square. And the loading and analysis for simply supported beam, the design action is 36.83 kN per meter, while the shear force is 101.282 kN per meter, while the bending moment is 139.26 kN per meter. Then the specification for continuous beam, the effective span L is 4000 mm, dimension is 150 mm, and the depth is 400 mm. And the permanent GK is 3 kN per meter, and the variable QK is 1 kN per meter, followed with the design life of 50 years, fire resistant R60, exposure cement XC1, and the material is same as simply supported beam. And then the loading and analysis for continuous beam, the design action WD is 5.55 kN per meter, and the shear force is 4 kN in the outer support, and inner support is 5.6 kN.
Next is method statement in structural part. The method statement that we have chosen is roofing works. So what have we done in roofing works? It is to outlining the installation of requirements and methodology for roof installation or assess or work on the project. So the standard that we have chosen in making the roofing works work is R. First, the roof tile shall conform to MS 797, and then the second one is pattern conforming to BS 402. So the safety measures that we have taken during the roofing works are the first one is the perimeter to locate a location to stand, the scaffolding to allow full edge protection, working platform, and safe access. And then earlier inspection needed to be carried out to detect the defects. These are the some roof works that we have done, which is the first one, lifted roof materials to the roof area under the control of lifting operations, and fall protection is fully geared either by permanent edge protection, and then roof batten lifted to roof by crane, and sufficient quantities of roof stales will then be transported to the working area. Material stored on the roof will be distributed evenly and away from roof edges. Lightweight materials weighed down to prevent them from being blown away. Continued with fixing the roof steel slates to the battens using copper double nails. Filled with cement mortar for the gable and roof tile edge. Lastly, debris or rubbish chewed with a hopper at ground level was used to remove existing materials. Okay, that's all for roofing works. Next method statement in structural part is curing work. Curing is given to freshly cast concrete segment that aims to prevent loss of moisture from the concrete for a certain period. So the standard that we have followed is Arahan technique developed by JKR, and then it is in curing work applied to all in situ concrete casting. Curing period depending on the outside daily average temperature and the types of the cement. So some of the safety measures that we apply during the project is concrete mixture has to be appropriate mixing, ensure the concrete casting has proper compaction, The curing process shall be having adequate curing to produce a product with strong strength. And then the concrete curing. The process of concrete curing is, after the placement of concrete was done, it shall be covered from wind, high temperature and rain. The process started as soon as the free water has disappeared from the concrete surface after placing and finishing. And then the curing method consists of several methods, which are first spraying water and curing compound, which is basically mainly used in vertical walls, beams and shear walls. And then the second one is by using wet gunny bags, mostly used for slabs.